This is class 221B. We are group 6. We are doing our lesson 10 stuff. All right. So before we start part 1, anything on part 2 that you guys think we need to go over? Sorry, before we start part 2, anything on part 1 you think we need to go over?
No, everything was just kind of going over what the lesson.
Yeah.
Thought, so.
All right. So part 2, number 6. What are the 3 assumptions that need to be checked before you compute a confidence interval for a mean?
So the sample has to be a simple random sample.
Yeah.
And it also has to be, the standard deviation has to be known.
Yeah.
And for the last one, it's either the population has to be normally distributed or the sample size has to be greater than 30.
That is actually sort of the second one. The third one is sigma is known.
Let me see. Okay, yeah.
Basically, we are calculating right now when sigma, the population standard deviation, is known, which makes our formula work. Next lesson, we're going to be doing when it's unknown, and so they'll be different.
Okay, that sounds good.
Someone want to read this section right here?
I can read it. The graduate management admissions test is used as an admission criterion in many Masters of Business Administration programs. The UIUI professor would like to estimate the population mean from a simple random sample of 50 people scored. The sample mean for these 50 students is 541, assuming a population standard deviation of 32. Answer the following questions. What is the point estimate for the population mean?
This one
41.
So the point estimate is essentially the sample mean.
Yeah, so this one's kind of confusing because it's a little overcomplicated. Basically, all it's asking for is the point estimate is the same as the population mean. So like the sample mean the same as the population mean, but it's the way they ask it is confusing.
Yeah. Yep.
Create a 95% confidence interval for the population mean. Show all your work below. Basically, if you haven't learned the formula yet, it's your point estimate population mean minus mu minus your margin of error, and so that's your z-score, which is based off. So 95%, you go to the normal probability outlet, color in the middle, and put 95 for the area, and that's your z-score. Then you one sec. Then you divide that, you times that z-score by your sigma, which is your standard deviation, divided by the square root of the sample size.
Okay.
Yeah, so that's gonna. So essentially, what this is getting at is just saying what our level of like our margin of error is. So that's why you're doing the plus and minus, because it gives you the range.
So the confidence interval is simply your mean that you're supposed to be trying to get minus your margin error and plus your margin error to get a lower and higher estimate of where your interval should be. So we have a 95, it's 95%. That means you have a 95% confidence. All of the numbers we're going to get are between this lower number and this high number. And if they're not, then we either did the math wrong or you have an unusual number.
Okay, makes sense.
Say that the sample size changes to n equals 100. Compute a 95% interval with the same point estimate. I put it right here. How does the margin of error for the 95% confidence sample of 50 compared to the margin of error of 95? Now, my page kind of gets skewed when I start any answers. So 9 is this the numbers. We get the same numbers. 534.728, 54. I don't work with numbers, but yeah, my page got skewed. Sorry. The big thing we need to know about this is when the sample size increases, the width decreases. So if your margin of error is, say, 10 to 15 or 10 to 20, and your sample size decreases, or sample size increases, your margin of error is going to compress and be like 12 to 18 or something like that. That makes sense?
Mm-hmm.
So the sample size, because it's inverted, anyway, basically the point is when the sample size increases, your confidence interval decreases. The same thing with if you have a smaller number here, so the interval for confidence interval is 90%, then it will also decrease because the confidence interval is a smaller number. You're just timing by a smaller number. That makes sense?
It does. I'm going to turn my microphone off because someone's playing the piano. And so that way it doesn't bother you. If I have to talk, I'll just take it off.
Yeah, that's fine.
So that makes sense though.
All right. The 10 is how do you compute the 10 is talking about how to compute the sample size. Basically, it's using the formula we have up here and for margin of error, and we reverse engineer it. So in the sample size, we are taking the square root of, so we get z critical times sigma times m squared. That may be wrong. I had trouble importing it in there, but basically all you do is you take the margin of error formula and you reverse engineer it. Does that make sense? We've done it before, so that's it. Let's go on to the group quiz. Any questions?
No, I don't think so. Oh crap.
Yeah.
I started the homework quiz, not the group quiz.
That's not good.
This is 10, right?
Yeah.
There we go.
All right. So number 3 computed, and then we'll talk about it. 90% is 1.645. What do you guys get it yet?
Hold on, not there yet.
All right.
It is 25. Oh. Sorry, I'm really slow at calculating.
That's cool.
$16.45. I kept saying that, and my microphone is off. I forgot.
Yeah, that's what I got too. Are you at church?
No, I'm just in one of the buildings on campus. I was studying for a math exam I have, another math class exam.
Oh, that's right. You're taking a second one.
Yeah, and then I remembered we had to do this, and I was like, oh man! So I went and found a room.
What did you guys? Oh, what did you guys get?
16.45. That what you got, Davis?
Mm-hmm.
I got 3.29. Oh, we have to do both and. You do 50 and then you do 25, right?
Say
No.
it again.
Wait, 16.445?
Yeah.
Rounded. What are we doing? Rounded it to 3 decimal places?
Well, I just got 2 decimals.
Huh. Yeah. 450.
So essentially what we're doing is the equation just to get the standard deviation is sigma over the square root of the sample size. So that's 50 over the square root of 25. And then that times 1.645 because it's a 90% level of confidence. And so it gives us 16.45.
Yep.
I did mine wrong. So how do you adjust with the 50 and never mind. Way off. Sorry.
No. You're good. The sigma goes over the square root of the sample size, which is 25.
So remember, sigma is your population standard deviation. So in order to find the sample standard deviation, we take that over the square root of sample size. And because we're looking for the confidence value, we times that by our confidence value, which is the z-score of the middle section of the confidence they give us. So for 90%, I should have it up here. You put the middle section and put 0.9, and that gives you the z-score.
Why is it just the middle section?
That's what they said in the thing. Basically, you don't. If you're doing these two, it would be the extremes. We're looking for everything in between this section. That makes sense.
90% between the two. Okay, yeah, that
Yeah,
makes sense. That's where
it's right in the middle, right? It's just saying what's the margin of error. So it's like from the right to the left, and that's just the boundaries it gives us.
Yeah.
Okay, that's where I went wrong because my z-score was different because I did everything under.
Yeah, he did say in the video that most of the z-scores we're using in this class are 90, 95, and 99, but there's a possibility we could use something different depending on what our sigma or what we're computing. So it's good to know how to get it. So you should probably try and memorize those 3 numbers of 90, 95, 99. But knowing how to get it is good because if you're in a real life situation, it's probably more messy.
Definitely.
Yeah, I was just about to say the exact same thing. It's nice to have them memorized, but if not, it's also nice to have them to be able to figure out how to get them manually. So
yeah.
I got 34.03.
Huh.
So
You got that.
Can you tell us what you did for your calculation, Spencer? Just walk us through. Maybe we can find something.
all right. So let's see here. Show you on my paper. I have my numbers all. Yeah, never mind. I was wrong. I placed the 25 and the 50 in the wrong spot.
All right, that would make a difference. Let us know when you guys are ready to move on.
You guys,
I'm good.
yes.
All right, cool.
Well, you guys' formula look like this. Can you see my paper? So you got 25 is the n equals 1.65 times 50 squared.
Oh,
Divided by m. Is that what you have?
no.
No.
I think
So
we
it's-
did.
It's 1.645, which is the z-score, and you do that times 50, which is the sorry, what number was that? 50, which is the standard deviation, divided by the square root of 25.
Look, this is the formula here.
So let me see if I can pull it up in the textbook. I have it up right here. All right. So here's a known for the margin of error. It's the 2 is representative of the z-score, and sigma over standardization of m. That's the margin of error. That makes sense?
Okay, yeah. I did the wrong formula. Wow.
Yeah, the book is kind of confusing because it uses an actual number instead of putting in z. I think it was a mistake, and they meant to put z, but they put a bunch of 2s. But the margin of error is the z-score of your confidence value times your sigma over your n square rooted. That makes sense, Spencer? You good? Can we go on?
That's using the wrong formula, so my bad.
Yeah, that's cool. So number 4.
That's the second one.
Yeah.
So number 3, what was the answer then? Sorry.
16.45. And if we get it wrong, we'll try it again.
Yeah.
Which of the following statements is true?
Second one.
Yeah, I agree. Someone want to read the information for 5?
I can do that. So Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size of 64 and computes the mean is 526. So what is the point estimate for the true GMAT score?
Wouldn't that be 526?
526, yeah. Makes sense to me.
Yeah, that's true. All right, now we're going to do the margin of error again. So this, remember, the margin of error in this one is 95% confidence. So when you're getting for the number, if you don't have it memorized, you do 0.95 in the middle section of the probability outlet, and that will give you a z-score of 1.96.
Yep.
So it comes out to 27.68.
Oh, okay, cool. You're fast.
27.68.
Someone double check me though.
Yeah, I'll. If Davis hasn't already done, I'll do it.
Oh no, I just took it first.
Yeah, I'll double check it. That's fine. Yeah, 27.685. Let's add the 5.
Oh, that's right. Yep.
I don't want to lose points and not doing 3 decimals.
No, seriously, like
Yeah.
we're being 0.005 off.
5,000th of a percentage.
Yeah.
But to be fair, and when you're talking about huge populations, it makes a difference.
Oh, for sure.
So we good on 6, or you move on to 7?
Yep, let's do it.
All right. So this one, all you're doing is taking their point estimate and subtracting and adding those 2. The first one we're subtracting. So our point estimate.
So that's how you find the lower limit then?
Yeah, so 526, which is our point estimate, minus our margin of error, which is 27.685, and then that's our lower limit. And then if we want to find upper limit, we do the exact same thing. So I got 498.315. Someone check me on that.
I just did. You're good.
And then if we want to do the upper limit, you just do the opposite. Instead of subtracting, you add.
So 0.395? 498.395?
Yeah, 315.
Oh, 315. Yeah.
Is it making sense, Davis?
Yeah, totally.
What's the mean again?
526.
So the top is 540.125.
All right.
540.
That's weird.
Yeah.
I got 553.685.
Yeah, there's no right. It doesn't make any sense.
Plus 27.685. I got 553.685.
Yeah. You guys are right. Sorry, I forgot to multiply by 1.96.
Okay. Yeah, in this case, when you're dealing with upper and lower limits, all you have to do is just use the same margin of error. So when we got the margin of error up here in question 6, we can just take that and just add and subtract that. We don't have to do anything else to it.
Sure. I just get lazy and I don't want to write it down, so I just keep doing it in my calculator and then I mess up more.
Yeah.
Well, and sometimes like you want to be careful though, because oftentimes you don't want to round before you know what I'm saying. So you might actually want to do it all the way through, like
yeah, no, that makes sense. This one I wasn't too worried because only 3 numbers had shown up. But if I had got a number that looked like it was a continuing number, then I would have just kept doing it.
Yeah, for sure.
And so they always tell in math class, if you have a number that's one of those like infinite numbers that has like the bar front, you know what I'm talking about, like pi stuff, then that's where you want to always. You don't want to round when you're doing the actual number. You want to use it as it is on a calculator. If you get rounding errors when you round it before you finish the calculation.
Yeah, for sure.
That makes sense, guys.
Mm-hmm.
So 9.
Decrease.
Yeah, decrease. We talked about this. The width of the confidence interval decreases if the sample size increases.
So it's decrease.
Yeah. So number 9 is
increase the sample size. Yes. Okay. Yeah.
Number 10 is increase. That makes sense. Why?
This is where Gina changed it to a 99%.
So if you're going from 95, right, 95 to 99, you have a bigger number you're timesing it by or adding by because so that means.
But you're multiplying by, yeah. So that makes sense.
I mean, all it do is you just got a bigger number, and the reason sample size is different is because you're dividing by the sample size.
By the square root of the sample size.
Yeah, and so when that increases, because it's a division point, it reverses. When it's multiplication, it's just increase. It's a little confusing. We kind of got to think back to your old school stuff.
Yeah, makes sense.
All right, number 11. I'll read this. The Bright Bulb Light Bulb Company is planning a study to assess average life expectancy of light bulbs. They know the standard deviation is sigma equals 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So this is what Spencer did on this first formula. We take, we're looking for n. So let me see if I pull it up. Right here, n equals z times sigma over margin of error squared. So we're looking at a sample population. Confidence value is 1.96. 400. All right, you guys get it yet?
No, so it's just z times sigma over m squared, right?
Yes. And so you want z times sigma on the top, the margin of error on the bottom. So the whole z times sigma, the whole thing is divided by 50 squared. So just make sure you got those parentheses in the right spot. I'll be right back. My dogs are barking.
I got 245, but we need to round 246.
Yeah, I got 245.866.
245.866. I got 862.
So on this one, though, we would round to the whole number.
Oh,
Yeah,
so
did you
246.
calculate it the whole time, or did you write it down? I rounded late.
Yeah, I probably rounded early. So, but anyways, we have to round to the whole number. So it's just 246.
Yeah. That's,
Oh, okay.
sorry about that. There was a squirrel taunting my dogs. All right. Someone want to read this information?
the mean salary of actuaries is $100,000, and the standard deviation is $36,730. You are interested to know if the mean salary for women actuaries is different from the population mean, but you are not sure if it is higher or lower. You set up a hypothesis test with level of significance of 0.05, and then you have your hypotheses there. You collect a simple random sample of n equals 30 women's salaries, and find that the population, or the mean whatever, is 111,000. So what is the lower limit of this 95% confidence interval?
Okay.
So we're gonna compute this. We need to compute the margin of error first.
Mm-hmm.
Yeah, it's just giving a lot of information that we don't need. So
yeah, exactly.
We'll probably need it later on.
Probably need it later in the question, the thing. But
well, if you're gonna do more math classes, get used to information dumps and then figuring the stuff out. All right. We know where to start. You take the 110,000. So minus or plus, so sort of lower limit, so minus. It's 95% confidence, so that's 1.96 time. And so our
it's going to look like 100,000 minus 1.96 times 36,730 divided by the square root of 36. That's how you find it, right?
Yeah.
Okay. And then obviously the opposite of that too.
I think I did it wrong. Let me be a negative number. Oh, now I missed a 0 on my first number. There we go. So I got 98,001.53 continuing.
988,000. 988,001.5333333.
All right, yeah. So let me write it down. Is this what you got?
One.
Or is it different?
Oh, but we're rounding to the nearest whole number, so it'd be 2.
But is this what you got?
98002. Yeah.
All right, just checking.
I got 988002.
All right. Let me double check my math.
That's probably really wrong, though. That seems really wrong.
yeah.
What do you get, Dave? Camden?
Oh, free. Because I put an extra 0 in. My bad. Yeah. You're right.
I got 98,781.
Okay. We should all probably just check our math again.
Well, what's the? Hang on.
So the first number should be 110,000 because 110,000. So make sure you got 4 zeros there. Then the z-score is 1.96. Deviation is 36,730. So 36,730. And your sample size is 36. So you should have the square root of that. I'm not noticing any problems in my math, but if you're getting something else, let's just double check.
Yeah, that makes sense.
I got 88001. What the fuck is going on?
Where are you getting, Spencer?
I'm not there yet.
All right. Let us know if we need to go slower. What about you, Camden?
Well, I think I just set it up wrong because I didn't get that last one right.
All right, we can wait. It's not a big deal. I just want to make sure we're all on the same page.
Yeah, see, I just did it again and got 88001.53333.
All right, let me check my math. So, tell me what math you do, and maybe I'm not seeing it right.
So I just did 100,000 minus 1.96.
Isn't it 110,000 or 111,000? Sorry.
Oh shoot.
Yeah, I'm doing it wrong too. I just noticed that I get 110,000 instead of 111. That is 111,000, right?
Yeah.
All right, so I'm in 99,001, so 99,001.53. I think that's right. I think we're all just using the wrong X bar.
Yeah.
So make sure, guys, you're using this X bar equals 111,000.
Hey, I'm getting 99,001 or 002.
It's 002, but you're right. That's what I'm getting too.
Yeah, it was just that one number.
So I was off by
99,002. Yeah.
All right.
All right. Now we just do the opposite. You just add it.
Yeah, that's fine.
I get 122,998.
122,998. Yep.
Yep. And do you remember if we round up or down? Because I think we are supposed to round.
Round to the nearest whole number.
Because I think they. Let me check. I believe they said something about always rounding up, but I need to check that.
You might be able to search it on that page if you have a map. You do command. Yeah.
Let's see. Yeah, I'm not getting that part, but I seen the words rounding up. Let me. All right. Why don't we go ahead and try rounding up, and if it's wrong, I'll do the guinea pig and we'll do it. Okay.
Sounds good.
There's something in my brain that's telling me that I heard that before, but maybe it's something else. So.
Always round up, no matter what it was.
That's what I'm thinking. I think I heard something on a video, but we'll figure it out.
Okay.
I'll be the guinea pig. So there are 3 requirements you need to check and compute a confidence interval for a mean. They are yeah. All right, I'm gonna wait just a sec. I'm gonna submit mine, and then we'll figure out if we need to change anything.
12 and 13, sorry.
12 and 13. 12 was 99002. And then 13 was 122,998.
Okay, so
Yeah, so it was right. It was we round up.
And that was the last one.
So 13 was correct. It was 122,999.
Okay.
Interesting.
Always round up.
Yeah, so check the videos. I believe one of the videos they're talking about how because the confidence value is always rounded up, even if it was like 0.002. But I'm not 100% sure, so I would double check that.
Okay.
Cool.
But it worked here, so. All right, anyone need answers from my page, or are we good?
I'm good. Got 100%.
Woo!
I'm submitting mine now. So unless I put something
Well, the
wrong,
bio test.
yeah, 100%.
All right. How did you do on the math test, Davis?
I got a 93, I think.
That's not bad.
I think, like, I want to, like, look through, though, because...
Give me 1 second. I'm going to stop